we have understood how a differential equation looks like. We have understood that like all the equations, this too can have a solution or many solutions. Now the question is, how do we find one of it? How do you find a solution for a given equation? So we are looking at the very basic version, the very first version, that is first order, first degree differential equations solution. We're trying to figure this out. A few methodologies that we will be learning. One is integration itself, differential equation with variable separation. Of course, all of them use integration. So here we have three other methodologies that we'll learn. The first one is, I just read that. Second one is homogeneous differential equation. Third is linear differential equations. So when we have a set of condition that is satisfied, then we can use the particular methods. So I'm going to give you guys a brief idea about it, because having a good picture and then working with it makes sense. If you just learn a particular method for few set of problems, you won't be able to do that in your exam, because they won't ask you use this method or use that method, right? Here you're doing section by section, you guys know what method to use. Along with learning about the methodology, how to use it and all of that, you have to learn where to use it, when to use it, and given an equation, how do you solve it? What method do you use? That has to be very clear. So this brief introduction will give you guys a good idea. The detailed understanding or the detailed steps and all of that will be done subsequently. Now, the very first thing is differential equation with variable separation. So the basic funda over here is to separate, the name itself is telling. Separate what? The y's and the x's together. So basically the underlying principle over here is separation. And also factorization. Actually it's the same, right? But yeah, I'm just writing it. Okay, now this is simple and straightforward. Compared to other, it is so. If you guys feel it's also complicated, if you look at this too, you'll feel that is simpler. Here you try to separate them, x and y's together, x as 1 and y as 1. You won't be able to. In such a scenario, we can substitute v is equal to y by x. Okay, and then use method 1 and then resubstitute. So here the underlying principle is that we can't separate, but when we substitute v as y by x, then we are able to use method 1. If so, then we can go with this methodology. And after that, it's the same thing, a step extra, that's it. Don't forget to resubstitute. Anyways, we'll be learning in detail. Now, last one is linear differential equation. Here the steps are a bit more complicated. I won't be able to explain over here and it's difficult. And there is actually a tricky set of questions, which I would like you guys to think over, right? If I explain it directly, then it's no fun. For that sake, I'm not going to write much over here other than the underlying principle. So it's kind of a clue. So it depends on the derivative of e to the power of x. Then we are looking at product rule. Then chain rule. So these are some of the underlying principle. So others too, of course, can be used. There's some more small ones, but these are the major ones. Okay, my request is pause, copy everything. This will give you a good hint on what method to use when. That's more important or equally important, equal to that of learning the method itself. Okay guys, you can pause and have a look.